All right, so we're going to be doing writing systems of equations. When a system of linear equations represents a real-world problem, each equation represents a constraint or conditions of the problem. The solution represents the value of the variables where both constraints of the solution are met. For the problem given below, identify what each variable represents and write in words what each equation represents. So during this, what we're going to do is we're going to be writing equations as if we would normally do that. Reggie's parents require him to do a total of 16 chores a month. His chores include sweeping the floors and cleaning the bathrooms. His parents pay him $2 each time he sweeps and $4 each time he cleans the bathrooms. This month, Reggie earned a total of $52. So what I know is happening here is that he has to do a minimum of 16 chores. So that's where the total amount there comes from. We do not know how many of each one he does. Then we know that he gets paid $2 for sweeping and $4 for cleaning the bathroom. So that's where those numbers come from, and the 52 represents the total amount of money he's made. What constraint is represented by x plus y equals 16? This is the total number of chores he must complete this month. Now, to identify the variables, you would go back to the question where it says $2 for each time he sweeps. So we know that with the 2 being right here next to the x, that would be the number of times he sweeps. And the other one is $4 each time he cleans his bathroom, so it's the number of times he cleans the bathroom. Now, what constraints is represented by 2x plus 4y equals 52? This is the amount of money that he earned from the chores completed this month. When reading the question, you can see that that 16 represents the number of chores, which when we looked at was right here, and the 52 right here helps us see that that's the total amount of money that he made. In the following examples, which when I turn the page, we'll be practice writing our own systems by defining the variables, identify 2 constraints, and writing the systems of equations. So Evan's mom drops him off at Entertainment Zoo for 3 hours, and he buys him 11 tickets. So that's very important right there. Evan can spend his tickets driving go-karts or playing mini golf. So he's go-karting or playing mini golf, which each cost 1 ticket. Driving the go-kart tracks takes 10 minutes, and the game of mini golf lasts 45 minutes. How many of each activity can Evan participate in before his mom comes back to pick him up? So when reading this question, I can see that he has 3 hours, which is important for me to pay attention to. I noticed that it talks about minutes for each of those activities, so I'm going to convert the 3 hours into minutes. So I would do 3 times 60 is 180 minutes. I think that's a smarter idea to keep everything in the same units. Then I need to give a variable for each, the go-kart and the mini golf, and x is going to be the number of times that he goes on the go-kart track, and y is the number of mini golf times. Now, when we're talking about the constraints that's happening, he only has 11 tickets. So that would mean that Evan can do a total of 11 activities. Additionally, there's another constraint in the fact that there are so many hours that he's there, or minutes. So Evan has 3 hours or 180 minutes to complete the activity. Now what we're going to do is we're going to write the systems of equations. We're going to start with the number of tickets. Since each activity is only 1 ticket, we know that the number of times that he rides the go-karts plus the number of mini golf games that he plays is got to equal a total of 11 tickets. Then we look at our time. We know that the go-kart is 10 minutes, so that has to go with the x. So we would do 10x for those minutes, plus the 45 minutes for the mini golf. So 45y has to be a total of 180 minutes. So now we've identified our variables, we've written our constraints, and we've identified our systems of equations. Let's continue. So here we're going to identify the variable and write a systems of equations for each situation. Mr. Kingsley and Miss Harris are math teachers at Roosevelt High School. Together, the teachers make 345 copies a week. Mr. Kingsley makes 3 more than half as many copies as Miss Harris makes. We're going to write a systems of equations that represent the total number of copies Mr. Kingsley makes, x, so he's an x, and the number of copies Miss Harris makes, y, each week. So we know here that there are a total of 345 copies between the two people. So we're going to look at Mr. Kingsley, and Mr. Kingsley we're going to identify as x because it said, and Miss Harris is our y. So Mr. Kingsley plus Mrs. Harris would equal a total of 345 copies. Then we also know that Mr. Kingsley, x, makes 3 more, so we're going to add 3 to half as many as Mrs. Harris. So we're not actually changing him, we're identifying that he is equal to half of Miss Harris, which was y, plus 3 more. And in this case, I also identify that x was Mr. Kingsley, so Mr. K, and y was Mrs. Harris, so Mrs. H, and it's the number of copies they make. All right, so we have River Racing is a company that provides inner tubes for children and adults to float the river. The child tube has a diameter of 2.5 feet, and that's the child one, and an adult tube that has a diameter of 3 feet. River Racing owns a total, so that's important, a total of 160 tubes. And the total diameter of all the tubes is 340 feet. Write a systems of equations to determine the number of child tubes C and the adult tubes A. So when we're identifying this, we know that C is the child tubes, A is the adult tubes, and we're trying to determine how many they have. So we know that the adult tubes plus the child tubes is equal to a total of 160 tubes. However, if we're looking for the total diameter, the adults are 3, so we would take 3A, because that's the adult ones, plus the child tubes, which is 2.5C, is equal to 430 total feet. All right, let's keep going. Annette has math and science tests this week. She set aside 275 minutes for study time. She determined she needs to study for science 10 minutes, so science is 10 minutes, less than twice the amount of time she needs to study for math. Circle the name of the students who correctly wrote a systems of equations where the math test is X and the science test is Y. So we know that the math X plus the science Y is a total of 275 minutes. So when I look at this one's correctly written, correctly written, correctly written. So any of them are correct right now. But now, to study for the science test, so our science test was Y. So Y is equal to 10 minutes less. So I'm going to take away 10 minutes from the twice the math test. So 2 times X for the math test. So I can see that this one is not correct because it's adding 10 minutes and we need 10 minutes less. We see that the minus is correct here and the minus is correct here, but y is what we're equal to. So Marco is not correct, and Sasha is not correct. So this last one is our correct one. Okay, let's keep going. The tables below show the cost of yoga classes, 2 different studios. Studio A charges a mat fee of $25, so that's that one-time fee of $25, but Studio B has no initial fee. Write a system of equations that will determine the 2 studios' costs the same. So we have 2 things that we're talking about, our x and our y. Our x value is the number of classes, whereas our y is the total cost. So when we look at this, the number of classes represents a rate, which is our slope. We want to remember in this case, when in doubt, graph it out. And we want to graph it out so that we can find that slope. So in this case, we would find the slope for both of them. And we know that Studio B is proportional, so I can do y over x when it's proportional. 80 over 4 is going to give me 20. 120 over 6 is going to give me 20. 180 over 9 is 20. And the last one is also 20. So we know that when we write Studio B, it's going to be y equals 20x because it's proportional. So that's one of our equations. Then we have to write Studio A. So we have to find the pattern that is happening here. And we can see to go from here to here, it is a $15 rate. So that's going to be our rate or our slope in this case because it's a change in 1 right here. So that lets us know that that is going to be our number of classes. So when we write that for Studio A, y equals 15x, which x is the number of classes, 15 is that cost, plus our original fee. And at this point, what we can do is, since we have the slope and we have several points, we would do y minus y1 equals m parentheses x minus x1, because anytime you have a point and you have the slope, you can see what is going to be our equation. We could have also done for slope y2 minus y1 over x2 minus x1. Once you do plug all of that in, you get that your B is 25. And we will go through that in class as well in more detail, but when we're thinking about it, if we don't have a singular step here, then you would use the slope formula to find the slope, and then after you find the slope, you can use any points to do point slope, and that's how you can write that equation. We're going to write and solve the systems of equations for the situation below. Buston's Barbecue Pit sells sausage and brisket per pound. Rusty orders 2 pounds of sausage and 3 pounds of brisket for his family, and he pays $21. Marta orders 10 pounds of sausage and I would use elimination when solving. So I would, at this point, multiply all of this, which also, when in doubt, graph it out if you have Desmos, but I would multiply by a -5, which is going to turn into a -10s plus, which is a minus because it's a negative, so minus 15b is equal to a negative 21 times 5, 105. Then I would start solving, and these are eliminated right here, and I end up getting negative 15 plus 14b is a negative b, and that's going to equal also a negative amount, and you get negative $4.50, but I would divide by a -1 to eliminate that negative there, and b, or the cost of the brisket, is $4.50. I am then going to plug it back into the very first equation, which was 2s plus 3 times 450 is equal to 21. I then can start solving, and I get 2s plus 1350 is equal to 21. I would subtract 21 minus 1350, and I get 7.5. I then would divide by 2 and divide by 2 to isolate S, and S is 7.5 divided by 2, and that comes out to be $3.75. That is per pound. So there's multiple ways that you could have solved this. I liked the elimination method just because the numbers were simple enough to do that. Again, when in doubt, graph it out on Desmos. And if you have any questions, please let me know.